Hi everybody, Professor Burns here. I want to take a look at section 4.7, which is actually, it's an application of derivatives, but it's a little bit of an aside because we're going to go back and we're going to look at limits again. We did those way back when, so we're going to return to limits a little bit, but we're going to look at a way that derivatives can help us to evaluate certain types of limits. And so this is called L'Hopital's rule. And L'Hopital's rule there's a lot of backstory and historically about what happened and who discovered it and who figured out this rule. But the long and short of it is that this rule is going to be used to evaluate certain limits that are called indeterminate. So when you apply a limit or when you try to use direct substitution, and you get that 0 over 0 case, for example. In the past, we usually said we've got to do some algebra, we've got to simplify this in some way, but that technique doesn't always work, and we still need to have some sort of analytical way to figure out the limit. And so let's look at how this rule applies. First of all, just as a refresher, let's say you had a limit that looks like this. The limit as x approaches 2 of x squared minus 4 over x minus 2. So if you tried direct substitution, remember direct substitution from back in the day, that would give me 2 squared minus 4 over 2 minus 2, which gave us 0 over 0. And remember that we said that means there is a whole, and we see that this one, we actually could factor and figure it out that way. But an alternative is to use L'Hopital's rule. So what L'Hopital's rule says is that if you try to take the limit using direct substitution and you get what's called an indeterminate form, which 0 over 0 is one of these special indeterminate forms, then the limit of the function as x approaches a, and it has to be in the form f of x over g of x. So it's got to be an expression where you literally have a fraction, f of x over g of x. That will be equal to the limit as x approaches a of the derivative of f over the derivative of g. And so how does that apply to this question that we just worked out? Well, let's take a look. Let's come down here and look at this example. If we apply L'Hopital's rule, we saw that that was the 0 over 0 case, so that's indeterminate. The rule says this is equivalent to the limit as x approaches 2 of the derivative of x squared minus 4, so just 2x, over the derivative of x minus 2, which is 1. So now try direct substitution, and as long as you use substitution and do not get something that's indeterminate, that ends up being your limit. So if you substitute 2 in place of the x this time, you have 2 times 2 over 1, which gives me a limit of 4. And that is the correct answer. And I want you to observe real quick that in the old days, back before we learned this rule, we could have evaluated this limit by factoring x plus 2, x minus 2, and then using direct substitution, we would have gotten 2 plus 2, which gave us 4. And that was an option, and we certainly can still do that. But if it isn't a situation where we can factor or do some sort of more familiar algebra, L'Hopital's rule gives us a good alternative using the derivative. Other indeterminate forms that may come up look like this. So we may see infinity over infinity. That's another indeterminate form. There's a couple of other indeterminate forms that look a little different. If we end up with 0 times infinity, that's considered an indeterminate form. Now we have to rewrite the expression so that it looks like a fraction, and we can apply L'Hopital's rule, and we'll see some examples in class. But that is considered indeterminate. Same thing with infinity minus infinity. 1 to infinity and 0 to the 0. These are all the indeterminate forms that we could apply L'Hopital's rule to. Let's do another one. Let's take a look at example 2. First, try direct substitution. So if we do that, notice our limit as x approaches 0, we get 1 minus cosine of 0 over 0 plus 0 squared, which would be 1 minus 1 over 0, which would be 0 over 0. Again, we get that 0 over 0 case. So I'm going to go ahead and apply L'Hopital's rule. So this is equivalent to the limit as x approaches 0 of 1 minus cosine x, the derivative of that. Derivative of 1, of course, is 0. Derivative of cosine is negative sine, but there's already a negative in front of it, so that would be sine over the derivative of 1, or x plus x squared would be 1 plus 2x. Now if we put in 0, we would get sine of 0 over 1 plus 2 times 0, which would just be 0 over 1, which would be 0. And so 0 over 1, notice, is not indeterminate. 0 over 1, of course, would just be 0. So that is, in fact, the limit. And we can repeat L'Hopital's rule as many times as we need to. So if we were to do this again and we get another indeterminate form, just repeat it. Take the derivatives again. And we'll also see tomorrow in class, we'll do some of these examples where it's one of these other indeterminate forms and we see that we have to take an extra step to put it in the fraction form we need it to be to apply L'Hopital's rule. But as long as we start off and we get one of these indeterminate forms and we use direct substitution, we can go ahead and apply L'Hopital's rule and get the limit that way. So these are just some basic examples to kind of get our feet wet, but I will see you in class tomorrow and we'll do some practice.